Hello, algebra students. Today we're looking at section 6.9, which is function operations day 1. And we're going to be looking at adding, subtracting, multiplying, and dividing functions. So what does that mean to do these operations on functions? And first let's remind ourselves what is a function. And you may recall that a function is a set of input and output values, pairs of numbers that is. And in each pair you have an input and an output. And to be a function, each input value can only be paired with one output value. So the way we usually define functions is with a rule, such as the ones that we have here. This is a function. And so you put in some number for n, that's the input value, and you calculate f of n. Okay, in this case, put in a number for n, and then you square it, and then you subtract 1, and that gives you f of n for that particular value of n. And you can plug in any number you want for n, and for each of those you will get an output value we call f of n. So let's just look at one example. If we put in 2 for n, what would f of 2 be? Well, you put in the number 2 for n, and you get 2 squared minus 1 equals 3. So you would get the ordered pair the ordered pair that we've just established is 2, 3. So that's just, one example of an ordered pair we would get from this function. We could get many other ordered pairs. And again, this rule that we underlined, we say defines the function. Okay, so that's what a function is. What does it mean to add, subtract, multiply, divide functions? Well, you do these operations and you get a new function. Okay, in this example, let's look at example 1. I think that will help. Whoops. We have the function f of n. We also have the function g of n. And we're asked to find f of n plus g of n, or f plus g of n. Now this is two ways of writing this same thing. It's a new function that you get when you add those functions. And you can then plug in values into this new function. And for each number you plug in, each input value that is, you get an output value, and that's an ordered pair, one of the ordered pairs of that function. So how do you do this? Well, all you do is you add those two function definitions together. Okay, so we're going to add that plus that. So here we go. F plus g of n equals, we just add those together. So f of n is n squared minus 1. We're going to add to that g of n, which is negative 2n minus 3. Okay, so to do this, we're going to combine like terms. And we write them in standard form. Anytime you have a polynomial, it's customary to write it in standard form. So let's combine like terms on this. Well, we have the n squared. That's the only squared term, right? And we have minus 2n. That's the only term that has n. That's not squared, just n to the first power. And then we take negative 1 plus negative 3. Those are like terms, right? They're constants, and we get negative 4. And that is it. Okay, so that's how you add functions. You just write down the function definitions and add them, combining like terms. Okay. Let's look at the next one. So we have these two functions, f and g, f of x, g of x, f of x, g of x, and we're asked to find f of x minus g of x. So this time we will subtract. I'm going to write it as f minus g of x. I think that's the way they're written in your, well, actually they're usually written the other way. So for the rest of these, I'm going to write them in the other format. You can write it either way, but I'll go ahead and leave this one. F minus g of x equals, so we subtract these function definitions. There's f of x, right? And we're going to subtract g of x. Okay, and g of x is x cubed plus 2. So to subtract, you distribute the negative to each of those, and we can rewrite it then, distributing that negative. We have minus x cubed and minus 2. Write that a little bit better. Okay, so just combine like terms now. So, and we'll write them in standard form. So the largest exponent is this one, has exponent of 3. So we'll write it first, negative x to the third. Then next we have plus x. And then we have combined this negative 2 and negative 2. That's negative 4. Okay, so that is it. Okay, let's look at C. So we could write this, we're supposed to find f of a times g of a, and we could write it the way I've been doing it, like this. But on your homework, they're not written in that type of notation. So I'm going to write it the way it's done in the homework. F of a times g of a equals, and we now, as you might expect, we simply multiply those functions, right? So f of a is 2a minus 3. That is, we're multiplying the function definitions. Okay, so you might recognize what to do now. We sometimes call FOIL first, outer, inner, and last. But I just think of it as distributing twice. So we distribute the 2a times a cubed, which is 2a to the fourth. Okay, and then we take that 2a times 3, so that's plus 6a. And then we take the negative 3 times a cubed. That's negative a cubed. I'm sorry, negative 3a cubed. And then the 3 times 3, and that's 9. And we will change all, we'll combine like terms and write it in standard form. But there are no like terms, right? So we'll just go ahead and rearrange this a little bit. The highest exponent is a to the fourth. We put it first. Next is a cubed, so it goes next. And then we have plus 6a and plus 9. And that's it. That is f of a times f of g. Okay, I think we have just one more. And this is another. This one has a little. Oh wait, I've skipped one. We have two more. Let's do D. It's a quotient. We're supposed to find h over g of t. We have h of g. H of t and g of t. We're supposed to find h of g over t. So, and we can write it in the other form. Looking at how the homework does division, I don't think you even have any division on the homework, which is okay. So the other way of writing it is like this: h of t over g of t. Just two ways of writing the same thing. Okay, these are the same. We're dividing the h by g. It's just two ways of writing it. And it creates this new function. So h of t is negative 4t plus 6. And g of t is negative t plus 8. Those are the function definitions. Okay, so now what do you do with that? Well, this is a quotient of two functions, and this is a pretty convenient form already, but we will reduce it if we can divide all four of those by the same number. If there's a number that divides into all four, we go ahead and reduce it. And 2 does go into all of those. So negative 4t divided by 2 is negative 2t. 6 divided by 2 is 3. Negative 2t divided by 2 is just negative t. And then 8 divided by 2 is 4. So if you can divide the same thing into all four, you go ahead and reduce it. And there is that new function, h of t over g of t. Okay, we have one more. And we have these two functions defined. The operation we're asked to do for this one is a little more involved. We're not just multiplying, we're not just adding the functions. That is, first we're multiplying each by a constant. So this says 3f of x plus 2g of x. And we're multiplying by that 3, right? And then we're multiplying g by the 2, and then we add them together. Okay, so what we do with that is just what it looks like. So we take 3 times f of x, the function definition, which is that, 2x minus 1, and then we add that to 2 times g of x. So we use the function definition of g of x, which is x squared plus 7. Okay, and then we just go ahead and simplify this. So we have to distribute the 3. 3 times 2x, 6x. 3 times negative 1, negative 3. And distribute the 2 over here. So that's 2x squared plus 14. And now we combine like terms, write it in standard form. So first is the 2x squared, and then next comes the 6x, and then we're going to have to combine like terms. Negative 3 plus 14, that's negative 11. So we have it. And that is 3f of x plus 2g of x. So that's all the examples. Now on the homework, the second half of the homework is something we haven't gone over today, function composition. So for now, you just do 1 through 8 on the homework. That's all.